Today we are talking with Hank Greely, the author of End of Sex and the Future of Human Reproduction, who also happens to be a very well-known professor that focuses mostly on the teachings of how the ethics and the bioethics, or biosciences and the ethics and social and other legal issues all come together or collide or at a cross point. Welcome to Readara.
Thank you very much. I'm happy to be here.
The book has an interesting title, but many people may miss the cut and the core of the book. What is the book all about, and what is the central message of the book?
Fundamentally, the book is a prediction. It's a prediction about how human reproduction is likely to change in the next 20 to 40 years. I think one of the things I learned in writing this book is if you're going to make a bold prediction, it probably makes sense to set its time frame past your lifespan. So I don't expect to be around in 40 years, so I can never be proven wrong to myself on this prediction. But it is a pretty bold prediction. I predict, and I genuinely believe, that in 20 to 40 years, most people having babies who have good health care, so everyone in rich countries, many people in middle-income countries, middle-class and well-off people in poor countries, will not conceive their children in bed or in the back seat of a car. They will conceive their children at a lab. They'll go to a clinic and make embryos. They will make about 100 embryos. Each of those embryos will then have a genetic test for its entire DNA contents, its entire genome sequence. And the prospective parents will be asked, which one of these 100 do you want to try to turn into a baby?
So what you're saying is that most people will have a choice either to have a natural conception or go in some kind of a lab and test it out and then choose that way. And most people are likely to choose that way because it is a better way to do it.
I think that among people who have that option financially, so it'll be a long time before everybody in Burkina Faso or in the rural parts of Laos have this option. But everybody who has that financial option, I think some of them will continue to conceive the old-fashioned way because of religious beliefs or philosophical beliefs or romantic beliefs, or they're teenagers and that's just what teenagers do. But that the majority of people will instead go to the lab. The main reason they will do this is to try to avoid the birth of probably the 1 to 2% of babies that have a serious, predictable, immediate genetic disease, and another 5 to 10% of people who have longer-term, very high risks as a result of their genes.
Mm-hmm.
This system would allow you not to ensure that you would have a perfect baby, not to ensure that you would have a healthy baby, not to ensure that you had some sort of designer baby, but of the babies that you and your partner could make, that you've got one that is not going to get or has very low chances of getting any of a number of really nasty diseases. I think many parents will find that very attractive. I also think public health systems, public and private health systems, will find that very attractive because preventing the birth of one child with a really serious genetic disease will save a health system millions of dollars.
So there's more predictability, there's a more kind of a choice in the way you go about doing this, and also it improves outcomes, it improves your odds at what you probably will have, not that what you want, but what you can have.
Right. I do think that it will get complicated. People will have at least 5 different kinds of things they can look at and choose from. One will be those early, really nasty, bad diseases, Tay-Sachs disease, where healthy babies are born and within 4 years they die as their brains basically disintegrate. That's a terrible disease, but it can be genetically predicted. Sometimes people will choose against diseases that happen later in life. So about 1 person in 1,000 has a genetic mutation that inevitably causes early onset Alzheimer's disease. They get the disease in their 40s or 50s. The only way they will not die from Alzheimer's disease is to die first from something else. You can predict that and other disease risks in advance. You can predict cosmetics to some extent, hair color, eye color, skin color, height, nose shape, whether your hair is likely to turn white, whether you'll have male pattern baldness. Those things are relatively unimportant, at least to most of us, but will be predictable. You'll be able to make a few predictions about behavioral traits, personality types, math ability, music ability, sports ability, IQ. I don't think we'll be ever very good at that because behavior is really complicated, involves hundreds of genes and lots of environmental influences and lots of chance. But in 40 years, we may be able to say this embryo has a 65% chance of being in the top half in, say, music ability, and a 14% chance of being in the top 10%. That's not a lot of information, but it's a little. And then the fifth category, and one that is the easiest one to do genetically, and one that a lot of parents care about, boy or girl. So I foresee a future where parents will make 100 embryos. They will be asked, what information do you want? They'll be told that information, and then they'll be asked, okay, which of these 100 embryos do you want us to transfer into a uterus to try to make a baby, to try to make your baby?
Give us a little bit of recap of where science is and where science will advance or is likely to advance in the next 3 to 4 decades. Obviously right now in this industry there are a lot of IVF and there are so many different kinds of acronyms there. Maybe take us on an acronym tour and simplify along the way. Where do we stand today and where we are likely to end up in three decades?
Happy to. And the most important acronym for this review is PGD, which stands for Preimplantation Genetic Diagnosis. Sometimes it's called PGS, for Preimplantation Genetic Screening. PGD involves taking an embryo, taking one or several cells from that embryo, doing genetic tests of those cells, and using it to decide to understand better the genetic pluses and minuses of that embryo and make a decision whether you want to try to turn that into a baby. Right now, that's widely used by people who have a bad genetic disease in the family and would rather find out before they transfer an embryo, before they start a pregnancy, than say 20 weeks into the pregnancy and decide to have an abortion. It's used by people who want to know boy or girl. Who want to pick boy or girl. It's used sometimes by people who have a relative who has a disease where she needs, say, a bone marrow transplant or a cord blood transplant. So it's been used to try to make babies who would be a good match to give bone marrow or cord blood to a sibling. The Brits call that save your sibs. So it's been used for like this, and most people have never heard of it. When I describe this to most people in most audiences, 85 to 90% have never heard of it. The oldest child born as a result of PGD is now 26 years old. This has been a clinically available service since 1990. In the US in 2014, the last year for which we have data, probably about 4,000 children were born after this process. So it's not designing babies, it's not editing genes, it's selecting which embryos based on the genes they received. And it's PGD, it's been around for a long time. And it is safe and effective, as safe as IVF. None of these babies is born missing an arm or a leg or a head because the other cells make up for the ones you take off. Now, the biggest problem that has limited the use of PGD is to use PGD, you've got to call in another acronym. You have to use IVF, in vitro fertilization. In order to take cells from an embryo, you have to know where the embryo is and be able to grab it. And if you get pregnant the old-fashioned way, or I should say if you conceive the old-fashioned way, 3 to 5 days after conception, where is that embryo? Halfway down one of the woman's 2 fallopian tubes. Good luck finding it. If you conceive via IVF, where is that embryo? In the petri dish you put it in, because they don't crawl out and move around. They're easy to find. That's been a problem because IVF is a problem. IVF is expensive, unpleasant, and dangerous. At least it's unpleasant and dangerous for the woman because egg harvest is unpleasant and dangerous. Sperm harvest is rarely unpleasant or dangerous. But for women, egg harvest is a big deal. They get 30 days of shots of powerful hormones that cause mood swings and cramping and can actually cause hospitalization. And even in rare cases, every few years, somebody dies as a result. It's not something people do unless there's a really strong reason for them to do it. The future I foresee will change that because instead of harvesting eggs from women, we will make eggs from women. We can also do this with sperm. We're more likely to need to do this with eggs because sperm is usually easy to get. Eggs are usually difficult. What we will do involves research going on with stem cells. You've probably heard of embryonic stem cells. These are cells taken from early embryos that are destroyed. We know that the cells can make every cell type in humans. Scientists disagree about whether there are hundreds of different cell types or thousands of different cell types, but there are a lot. They all agree on that. Brain cells, kidney cells, liver cells, skin cells, eggs and sperm. The problem with using human embryonic stem cells is then the egg and sperm you would make would be the embryos, not yours. But about 10 years ago, a Japanese scientist named Shinya Yamanaka invented what are called, another acronym, iPSCs. It's a little I, capital PSC. That stands for induced pluripotent stem cells. And basically, he took skin cells, he hit them up with a cocktail of 4 different genes, and he turned them into things that look all the world like human embryonic stem cells. They're cells that can become brain cells and kidney cells and heart cells, and they can become eggs and sperm. Now, no one has turned human iPSCs into eggs and sperm yet. They've done it with mice, and healthy mouse pups have been born from eggs that were created from skin cells, mouse skin cells, and from sperm that have been created from mouse skin cells. They've so far, with humans, only gotten so far as to make cells that are on the pathway to being sperm. They haven't made full sperm yet. But one of the reasons I'm so confident this will happen is that research into iPSCs is going ahead very powerfully for reasons that have nothing to do with reproduction. In order to be able to replace brain cells for people with Alzheimer's disease, or liver cells for people with liver damage, or beta cells in the pancreas for people with type 1 diabetes. There are real advantages to using these things, and as you learn to manipulate them and turn them into particular cell types, we'll learn better how to turn them into eggs and sperm. That's why, in, say, 30 years, a couple goes to the clinic, the man gives a sperm sample, the old-fashioned way. The woman, instead of getting 30 days of powerful hormones, gives a little skin sample about 2 millimeters big. So that's about under 1/10 of an inch. So small that you don't need a stitch, you just put a Band-Aid over it. And those skin cells are turned into these iPSCs. The iPSCs are turned into eggs. The eggs are matured and ripened, and then you make embryos. And by the way, one of the other advantages of this system, when you harvest eggs from women right now for IVF, you get somewhere between 0 and 25 eggs. Usually you get about 10 or 12, but there's a pretty wide range. If you make eggs from stem cells, how many eggs do you get? How many eggs do you want? Tens, hundreds, thousands, millions. Just a question of how long you let the cell line continue to grow. So I think this making eggs from skin cells, and for some people, for men who don't have sperm, making sperm from skin cells is the biggest breakthrough needed to lead to what I call easy PGD. And I think that's highly likely to happen. The other breakthrough that would make easy PGD more real is already happening. That's cheaper and faster genetic sequencing. Right now with PGD, you typically only look at 1 or 2 or 3 genes because looking for genes is expensive and time-consuming. The price of looking at every gene in your body, every piece of DNA in your body, and learning the whole sequence, learning every character in your DNA. If you think about DNA as a book, and you think about the A's, C's, G's, and T's that make up DNA as letters and punctuation marks and spaces in a book, each one of your cells has enough DNA to be 1,000 copies of The Lord of the Rings, or the Bible, or War and Peace. We can now sequence that entire 1,000 volumes of The Lord of the Rings for about $2,000. 10 years ago, it cost $100,000. 10 years from now, it'll probably be $200, and 10 years from then it'll be $20. And so that's happening for reasons having nothing to do with reproduction, but it also changes easy PGD. It means instead of looking at just 1 or 2 traits, 1 or 2 genes, you look at everything. and you find out everything genetics can tell us about that embryo. It's not as much as most people think. Genes are not destiny nearly as much as most people think they are, but it can tell you a lot of interesting and important things about the child's future health, about how the child will look, a little bit about how the child will act, and quite a lot about whether the child will be a boy or a girl.
Fascinating. And this is all possible and very likely to happen in the next probably 3 or 4 decades.
Well, it's possible right now if you're a mouse.
Mm-hmm. Mm-hmm.
A lot of things are possible right now if you're a mouse. I think you could try to rush this and do it in humans in about 10 years. My own view is it should be more like a minimum of 20 years, because I think you want to spend at least 10 years making sure this is safe, making sure that these eggs derived from stem cells will give rise to healthy children. Because I can think of no worse thing, really, than to invent a new method that causes the birth of lots of disabled, sick, or dying children. So I would make sure this is held to the highest levels of safety, with research done both on human cells in laboratories, but also on monkeys, on other non-human primates, maybe even on chimpanzees before you start it on humans.
Mm-hmm. Mm-hmm. So the key breakthrough that we're going through along the way as well is that you don't need the sperms and you don't need the eggs. You can start just with the skin cells, and then we are along the way there in getting where we need to go.
That and the breakthrough of cheap sequencing that allows you to discover more information inexpensively.
Exactly, the full sequencing, right?
Yep.
Obviously, everyone will look at this possibility and will have their own way of looking at it. Lawmakers will look at themselves at this thing in a different way. Regulators will look at it from a different way. Ethicists will look at it from a different way. Religious leaders will look at it from a different way. And regular couples or unconventional or other couples will look at it different ways. And unfortunately, you may not even know that you just become a parent of a child if somebody gets a hold of your skin cell.
Yep. I think that's the one recommendation I have that I most firmly believe should be adopted. We should outlaw making people parents without their knowledge or consent. Right now, it's pretty hard to steal eggs and sperm, but if you can make eggs and sperm from cells, every time you drink a bottled water or a can of soda, you leave skin cells on that bottle. And when you throw that away, those could be retrieved and presumably, potentially, turned into iPSCs, which could be turned into eggs or sperm.
Does that also apply to dead people whose tissues are preserved?
Yes. So we're recording this almost exactly 20 years to the day after the birth of Dolly the sheep was announced. This method isn't cloning, but one interesting point about Dolly is Dolly was made from cells from a sheep that had been dead for 4 years. Her mother, father, progenitor, whatever you want to call it, the cell that gave rise to Dolly, had been frozen for 4 years after the sheep had been killed, and then thawed out and became Dolly. You could make eggs from a woman who was 25. You could make eggs from a woman who was 80, who no longer had viable eggs of her own. You could make eggs from a girl of 8 who did not yet have viable eggs of her own. Her eggs had not yet matured. You could make eggs from a girl of 8 days old, or a girl fetus that's 8 weeks old, or you could make eggs from cells frozen from a woman who'd been dead for 8 years. It raises lots of interesting possibilities about unusual family structures.
Yes, yes.
And let me add one more to that. And one of the things I think some people will find appalling and some people will find wonderful as a result of this, it would take one more scientific step, but it's a plausible one. It is plausible that we could take cells from you and me and certainly turn them into sperm. That's what my thesis depends on. But also that we could turn them into eggs. And we might well be able to take cells from women and turn them not only into eggs, but turn them into sperm. Why would anybody want to do that? Well, there are millions of gay or lesbian couples who would love to have children that are genetically their children. And right now they can't do that. The best they can do is use, say, an egg from one member of a lesbian couple and sperm from the brother of the other member. And that baby would end up 50% the genes of one partner and 25% the genes of another partner. But they can't have a kid who's completely genetically theirs. If you could turn, I call it cross-gender gametes, cross-gender eggs and sperm, If you can turn male cells into eggs and female cells into sperm, you open up that possibility, which some people would find horrifying and some people would find the best thing that ever happened to them in their lives. Whatever it is, it'll be different and controversial.
It will certainly change your thinking forever.
Yeah. I do think that we are in the most amazing time to be alive, in that our knowledge of biology has increased so much that the possibilities of really engineering life, of making major changes, are greater than they ever have been before, and they come in lots of different directions. So let's say you need a kidney. Well, we might think about growing a kidney for you in the laboratory. We might think about growing a kidney for you in a pig, grow a human kidney in a pig. We might think about growing a pig kidney that could be used for transplant because it's been changed so that humans will accept it. We might think of making a device that works like a kidney. We might think of fixing your kidney with stem cells or with gene therapy. All of these are real possibilities today. They're not real today, but they are realistic areas of research that could lead to treatments within 10 or 15 years. 10 years ago, they were dreams. This is an amazing time because of the huge advances in biology. And it'll be amazing in ways that will have good sides and bad sides. Every technology ever invented can be used for good purposes or bad purposes, and these biotechnologies are no different.
Now, certainly the way we see disability and the way we see the people with disability certainly will probably change, because if disabled parents may want to conceive or have a child because that's their way of life of another disabled child, will the lawmakers and regulators will catch up with that?
I think that's going to be really fascinating to watch. I do think that different countries and different cultures will use this in different ways. I think much of East Asia would be very excited to adopt easy PGD. I think in the US, most states would widely adopt it. The Vatican City is not going to adopt it anytime soon. And some of the more conservative Latin American countries with very strong Catholic backgrounds will not adopt it. Germany, because of its experience with the Nazis, is very reluctant to do anything in human genetics. Scandinavia is much more open. I'd be really interested. I don't have a good sense of where India is likely to be in that, and that is that in 20 to 40 years, that'll be the world's largest country in population. So some countries will regulate one way, some countries will regulate other ways. To me, the disability issues are the hardest. About 10 years ago, I hosted a conference on PGD, not easy PGD. I hadn't thought about it yet, but just straightforward PGD. And one of the panelists at the conference was a woman who represented a disability rights organization. She had a genetic disease called spinal muscular atrophy, which meant her muscle control was gradually declining. She was in her late 20s. She was in a wheelchair. Her brain was completely unaffected. And she said, "What you're saying is I should not have been born." I did not want to answer yes to that challenge. So I said, no. I'm saying that your parents would have had a choice of having a you born who had SMA, spinal muscular atrophy, or a you born who didn't have SMA. And she said, quite accurately, I think, a me without SMA would not be a me. It would be someone else. So I think one side of the disability issue is, what does it say to people with disabilities that society has now come up with a way to avoid having any more of them born? What does that tell them about how society values them? What effect does that have on their self-worth? More concretely, it says, how much research money is going to be spent on my disease if nobody's going to be born with it anymore? Or far fewer people will be born with it? Or how many doctors will specialize in treating my disease? And how much social support will I get? So there are all those issues. And then there's the issue you raised. Some parents with things that most of us think of as disabilities would like to have a kid like themselves. The two best examples of this, I think, are deafness and dwarfism. Deafness is actually a big disadvantage in terms of socioeconomic status, education, income, and yet many deaf people view deafness not as a disability but as a culture with its own language through sign language and its own important different ways of being human. Some of those people would like to have a deaf child. Will countries allow people to select an embryo knowing that it's going to be disabled? That's going to be an interesting question. The most common form of dwarfism is something called achondroplasia. The Munchkins in the movie The Wizard of Oz had achondroplasia. It has very minimal health effects. People live full, normal lives. Their intelligence is completely normal. Their biggest problem is the world isn't really built for people their size. Achondroplasics might well want to have a child like themselves. Would we allow that or would we ban it? I think those are going to be questions that many legislatures will wrestle very, very long with. But it's not just the legislatures. If you're a doctor or an IVF clinic, how do you feel about doing that procedure? Would you do it? Would you not do it? I think this new technology, like all the important new technologies, will raise more questions than it answers.
As science advances, do you see a possibility, as I think you brought it up in the book, which you touched upon a little bit, uniparenting and multi-parenting?
Yeah.
And I think maybe you want to expand on it a little bit, that, why somebody would like to do one thing or other, we don't know, but certainly the possibilities are there now.
Yeah, this opens lots of possibilities that are not obvious. One of them is what I call the uniparent. So let's go back to being able to make eggs from men and sperm from women. When I first presented this to my faculty, one of my colleagues, providing proof that law professors are not necessarily the most humble of people, said, wait, if I can make an egg from myself and I can make a sperm from myself, I could combine them and make an embryo from myself. And I thought about it and said, yes, you could. Why would you want to? But you could do that. It wouldn't be a clone, going back to Dolly, because every place that, say, you or I has two different versions of a gene. So say blood type. My blood type is type A, and I happen to know I have one type A gene and one type O gene. That makes me, because A is dominant over O, that makes me blood type A. But if I became a uniparent, made an egg from myself and a sperm from myself, 25% of those children or embryos would have 2 copies of A, 25% would have 2 copies of O, 50% would have one of each. So it's not going to be exactly the same, but it's going to be awfully similar. I have a hard time seeing why anybody would want to do that, but it's a big world. And there are people with narcissistic personality disorder, or at least with narcissistic personalities, who might decide having a baby that's very similar to themselves is the best thing they could do, best thing they could do for the world. So uniparents are a possibility. Mentioning Dolly, 20 years ago, people got terrified about the idea that there would be armies of cloned warrior slaves, or armies of Hitler, or armies of other kinds of clones. And then people kind of forgot about it because for 16 years, nobody was able to clone a human embryo. Well, 4 years ago, a group in Oregon successfully cloned a human embryo. They don't want to use it to make babies. They want to use it only for research. But in the future, one reproductive possibility may be cloning. And just to give it the appropriate acronym, since everything has to have an acronym, we would call it SCNT, somatic cell nuclear transfer. All these new possibilities are coming down the road. One of them that gave me trouble in the book because it really exploded just about the time I was finishing the book is something called Crispr, another acronym, clustered regularly interspaced short palindromic repeats. CRISPR is an amazingly cheap, easy, and effective way to edit DNA. It is 10 to 100 times better than anything we could do before. I like to think of it as the Model T of DNA. Before the Model T, there were automobiles, but they were really expensive and they were really fragile. You had to hire somebody who was a combined chauffeur and mechanic just to keep it running. But with the Model T, cars became an order of magnitude cheaper and much more reliable, and everybody could have a car. Well, with CRISPR, gene editing, which was difficult, has become really trivially easy. And at some point, I think 10 years later than easy PGD, at some point people are going to be able to have gene-edited babies, which would allow 2 people who were type O blood to have a type A child. Don't want anybody to want to do that. It might also allow 2 people with light eyes to have a child with dark eyes, or 2 people whose genes made it highly likely their children would be short to have tall children. That's another one of these technologies on the horizon. So some of them scare me. Some of them I think will be good things. by and large, but they all will challenge our views about the appropriate ways for people to make babies.
What we're not talking about is cloning, or we're not talking about designer babies. These are all different things, and this is just having a better outcome from the two groups of ingredients that we mix to get something new.
Right. Easy PGD just involves making a bunch of embryos from eggs and sperm from two people and letting those people pick the one they think is best, the one or the two or the three that they like best. That won't necessarily be the best possible because each of us has about 23,000 genes. And in order to make every combination of 23,000 genes, you end up having to make trillions and trillions of embryos. But if you make 100, you can pick one that is going to avoid the major genetic diseases and will have some other attributes you like. What it doesn't allow you to do, you can only get out what you put in. The two parents can only get a child who has genetic variations that those two parents have. In order to change that, you would have to go to a different technique to actually do gene editing and change the DNA of the child from what the eggs and sperm would otherwise give him.
I may be a famous scientist, or I may be, let's say, an Einstein. That means that there might be a market for my stem cells or skin cells, because there might be somebody who may want to mix it up and see whether I have a possibility of creating a child that could rival or potentially get to that level.
Yeah, it's interesting the examples you use. I think in some cultures and in some places, maybe Einstein would be the most valuable. In others, it might be a movie star, TV star, or an athlete. But yes, the possibilities, especially because you no longer need to actually give a sperm sample or an egg sample, the possibilities of selling particular people's eggs and sperm go up dramatically the easier it becomes to make those eggs and sperm.
Mm-hmm, mm-hmm. Obviously, family relationship will change. The family unit probably itself would be very different, because it's not going to be the traditional nuclear family that doesn't even exist nowadays, or is already in a different situation than it was just 50 years ago.
Well, Manish, I wonder about that. I actually think for the most part it will be whatever comes close to the nuclear family today in whatever culture you're in. I think most people will just use it to pick, using his sperm and her eggs, they'll use it to pick an embryo they like best. But it does open possibilities for using other people's eggs and sperm, using eggs and sperm from people who are too old to have children or too young to have children, or who have already died and can't have children as a result of that. Those possibilities are open as a result of this. I think they will be a small minority of all the ways this is used, but they will be one way it is used. I think the way this is first going to be used will have nothing to do with genetics. My view is the FDA or the FDA equivalent in other countries will first approve making eggs and sperm to treat people who can't have genetic children because they don't make eggs and sperm. Sometimes that's a result of a disease, testicular cancer, early ovarian cancer. In men, often mumps used to cause sterility. Sometimes it's a result of an accident. Sometimes it's a result of a birth defect. But for whatever reason, there are millions of people who don't make eggs and sperm, but might like to have a child. Maybe the most common reason is women who used to make eggs, who used to have eggs, but are now so old that their eggs are no longer viable. For those people, making eggs and sperm from stem cells gives them a chance to be genetic parents that they didn't have before. And I think that's a very politically attractive population, as well as a large enough population to give clinics and manufacturers and researchers an incentive to try to tap that market. So I think that's how it will first be used. And then people who need to do IVF for other reasons, say women with blocked fallopian tubes, will say, why should I go through egg harvest with its expense and its unpleasantness and its risk? I'll just make eggs from my skin cells. And then at some point, starting with a brave few, but growing as time goes on, people will do it in order to do the genetic testing and do the full version of what I call easy PGD. I think that's the entering wedge. I think of it as almost the flight path for this to take off. It'll start with treatments for infertility for people who don't make eggs and sperm, and it'll move from there.
That is a stepping stone before it moves on to a wider acceptance.
Yes.
So much about the book. Let's change a little bit of tracks here and talk a little bit about the author himself. How did you get into biosciences and technology and biology? You happen to be in the legal professions of where the words matter and the arguments matter.
I'm a law professor, a lawyer by training. My undergraduate degree is in science, but it's in political science, so that wasn't very helpful. Although it turns out it is kind of helpful for some of the things I do. The honest answer is I married a doctor, which got me interested in medicine. I'd always had an interest in science, and I became more and more interested in biosciences. In my early days as a law professor, I focused on health policy. But then in 1994, after Hillary Clinton's health plan crashed and burned, it was pretty clear nothing important was going to happen in health policy for several years. The Human Genome Project was starting up, so I got involved in the Human Genome Project. And since then, I've discovered that it's a wonderful playground. I have the best job in the world because I get to not only teach brilliant students, but I get to work on fascinating stuff that's changing all the time. So I started with genetics. After Dolly's birth was announced 20 years ago, I did some work on cloning. That led me to work on embryonic stem cells. I work on neuroscience. I work on assisted reproduction. I work on some cross-cutting issues involving research ethics and human biological enhancement. I've worked on de-extinction. I've worked on human, non-human chimeras, making human organs in non-human animals. All these things are the stuff that I read as science fiction when I was a teenager, but it's not science fiction anymore.
It is the state of the art.
Well, it's either the state of the art or it is
about to be.
It is in reach. It is plausible. It is something that could well happen and I think is likely to happen in the next 10 or 20 years.
Just imagining having dental implants or having, breast implants or having reconstructive cosmetic surgeries 25, 30 years ago was something that you would not even think about. Today it is becoming very common.
Or organ transplants. I remember the first heart transplant and the first kidney transplants. There are hundreds of thousands of people, probably millions of people alive walking around today because of organ transplants. There are an estimated 6 million people who are alive today because of IVF, children who would not be born, parents who would not have had children, but for the fact that IVF made it possible. And that's the oldest IVF baby is not 40 years old yet. So within my lifetime, I'm 64, we've had enormous changes, and the speed of change is accelerating. I expect to see more change in the next 20 years, if I get to see another 20 years, than I've seen in the first 64.
How was the journey in writing the book, collecting information, processing it, and packaging it so that common people can understand it?
It was interesting. So in one sense, this book was sort of an advertisement for the end of sex in one way. It had a gestation period of 5 years. And I think a 5-year pregnancy would put anybody off of sex. It took me 5 years to write it, but it actually only took me 5 months to write it. It took me 5 years to find the 5 months in bits and pieces to write it. And it was a wonderful expedition, learning the science, putting it together, seeing how it worked. This book is really kind of the scratching of an itch. In October 2010, I was at a conference in Germany where for the first time somebody mentioned the idea of making eggs and sperm out of stem cells. And I started wondering, well, gosh, what would that mean? And pretty soon I had the outline of a book. The bad thing about taking so long was the science kept changing on me, and the society kept changing on me. So there were constant adjustments. The good thing was I've been talking about this book from about the beginning of its conception, 5, 6 years ago. And I'll talk about it to groups of scientists and groups of doctors and groups of lawyers. I've also talked about it to local community organizations, to Rotary clubs, to groups of Stanford alumni, to high school students. I like to talk, but all of those talks helped me understand better how to convey this to people who aren't expert in it. What works and what doesn't work. And I found nothing is as good at helping you do that as practice. I mean, that's a pretty obvious thing. Practice helps, but I've probably talked about this to 100 groups, 50 to 100 groups in the last 5 years. And from each one, I learned something new about what works and doesn't work and how to explain it to real people.
We are very delighted to have you with us. Thank you very much for your time and wonderful comments. And certainly we would love to hear more from you if you write another book as well.
I've actually got another one planned, but I hope it won't take 5 years. It's called Playing with Life. And when I finish it, let's be in touch. I'd love to be interviewed by you for my second book.
Thank you. Thank you very much.